Right, hi everyone. So I want to talk about a property of inequality for logarithmic functions. Right, so the property that I'm going to get into today is if we have b greater than 1, x is greater than 0, well, then we have and we also have log base b of x. This should be greater than the value of y. Then we can conclude that x is greater than b to the power of y. Okay, so first off, let's just take a step back. Logarithms are an exponent. So originally we had, I guess we'll just call it OG for the sake of it. Okay, so if we had log base b of x, this was equal to y. Okay, logarithm of b, the base b, when it is x, is equal to the exponent. So logarithms are the exponent that you're looking for. Logarithms will give you the power, basically, of your base at x. So if I look down here, log base b of x is greater than y. Right? I want my exponent on the left-hand side to be greater than the number on the right-hand side, which is y. So this is why we get x is greater than b to the power of y. Now this is the instance of where b is greater than 1 and x is greater than 0. Now let's look at another instance. So here's our first instance, here's the second instance. If b is greater than 1 and x is greater than 0, and then this time we have it for less than y. Alright, now the exponent that I'm looking for at base b is less than a value of y. Then I can conclude that my x value is in between 0 and b to the power of y. Alright, so this is the property of inequalities for logarithmic functions. So let's look at an example. So let's look at one example. One example we have is, let's say, we have log base of 6 of x, and this is greater than 3. Okay, so by this rule, I have, well, this is the greater than symbol, right? So I have the greater than symbol over here. The greater than symbol is over in our first step, log base b of x greater than y. Then I can conclude that x is greater than b to the power of y. Okay, so I can say, alright, x is greater than my base, 6 to the power of 3. And then 6 to the power of 3 is 216 when you solve it all out, because 6 to the power of 3, 6 times 6 times 6, it's greater than 216. And then you're done. You have solved this problem. Alright, so let's look at another instance, and let's use the second instance in this one. Let's say I have log base 2 of x, and this one is less than 4. So by the rule, the property of inequality for logarithmic functions, right, let's just say by the rule. Okay, so our base b in this instance is 2, and my x is x, that's what I'm trying to find, and my y is equal to 4. Just using the rule, and I'm analyzing with the rule. Alright, so by the rule, and I have a less than sign here, I'm going to use 0 is less than x is less than b to the power of y. Our b was 2 to the power of 4. So we have 0 is less than x, doing 2 to the power of 4. To simplify this all out, we get 16. So this would be my final answer, and I have solved using the big fancy property of inequality for logarithmic functions.